Hi, this is Dr. Anjaneya Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about plastics and types of plastics and what are the engineering applications of plastics. First, we are going to discussing about what are the plastics. It is a material consists of a wide range of synthetic or semi-synthetic organic compounds that are malleable and can be molded into solid objects by applying heat and pressure. That is a definition of plastics. So, plastics we can define as the material which has tendency to molded when applying heat and pressure. So, the plastics are the material can be molded into our desired shape when you are applying some heat and pressure. That materials are known as plastics. So next coming to the properties. What are the major properties of plastics? Resistance to corrosion and chemicals. So plastics are does not undergoes corroded, does not undergoes corrosion. So we know that what is a corrosion? It is a degradation of material by the attack of foreign substances like different types of chemicals and gases and environmental conditions like wet conditions, etc., which are present in environment. So plastics has high resistance towards corrosion. And next property is low electrical and thermal conductivity. So conductivity of the plastics are very less. So most of the plastics act as a insulators. Next, high strength to weight ratio. So plastic has one more important property, that is high strength to weight ratio. Height and weight ratio is very high. And next, plastics are available in different colors as well as transparent. Plastics are resistant to shock and durability also very high bar in case of plastics. And with respect to cost also, plastics are very less expensive. And coming to the manufacturing procedure for plastics are very easy. And plastics also shows resistance towards water, and with respect to hazardous to the environment also very less. So low toxicity. So these are the definition and properties of the plastics. Next, some uses of the plastics. Architecture uses of plastics. So like pipes, electrical conducts, rainwater and sewage pipes, plumbing and gas distribution. So most of the pipes are made up of plastics. Next, cables. PVC insulation on cables, on insulation tabs, etc. And floorings. Nowadays, plastic is used as a flooring tiles and loads. And domes and skylights, opaque as well as transparent. Nest looping, curled and double skin for insulation. Windows and doors, extruded sections for doors and windows and panels. And next one is tanks, hardware accessories, washers, nut bolts, sleeves, and anchoring wires. Temporary structures, that is guard cabins and tents. And insulating materials, PVC sheets, insulating membranes. So these are all uses which are belongs to architecture uses of plastics. So you can see here, so different types of floorings which are made up of different types of plastics. Flooring, properties of the plastic flooring. So hard polypropylene used as a flooring, and soft PVC, soft polyvinyl chloride also used as a floorings. And durability, very durable, and plastic floorings used for garages and warehouses, and plastic flooring capable of supporting extreme weight loads and resistance to oils and solvents. These are all plastic floorings, different types of plastic floors. And coming to the plastic walls. Nowadays, in some of the countries, walls also made up of plastics. Like in commercial kitchens, bathrooms, washrooms, canteens, and food processing areas, changing areas, fast food outlets, and food storages. So, in a wide range of areas, plastics walls are has been used. Advantages of plastics as a building materials. In some countries, houses, different types of plastics are used in construction field. So what are the advantages? Let us see the advantages of a plastic as a building materials. So plastics are strong at lightweighted, they are durable, knock and scratch resistance with excellent weather ability, do not rot or corroded, and very easy to install, offer limitless possibilities in design achieved by extraction, bending and molding, etc. They can be given an range of colors by adding pigments. The plastics are low conductors of heat and thus are used as insulation materials In green building concepts, the plastic products can be achieved tight seals and they can be sand and nailed employing standard carpentry tools and skills. They can be easily removed and recycled. So these are the main advantages of plastics when using in construction field. Next, coming to the disadvantages. Plastics may be degraded under action of direct sunlight, which reduces their mechanical strength. Many plastics are flammable unless treated, unsuitable for road bearing applications. Thermoplastics deform and soften at moderate temperatures. So these are the main disadvantages. Next, structural plastics. It is a one type of plastics. Structurally engineered thermoplastics are an excellent alternative to metal in applications where strength, dimensional stability, and toughness are important. Structural compounds offers dramatic improvement over neat resins in stiffness, tensile strength, load bearing ability, and other properties, including short term temperature resistance. And next one is reinforced plastics. They are recent class of composite materials. So what is a composite materials? Mixing of different materials by adding or mixing of one material to another material to enhancing the properties. Some important properties of that material is known as composite materials. So reinforced plastics are nothing but composite materials in which the low modules and temperature limitations of the plastics is overcome by reinforcing it with fibers and high modules. Reinforced plastics also known as polymatic composites and fiber reinforced plastics. So these are consist of fibers, discontinuous and dispersed page in a polymer matrix. These fibers are strong and stiff and they have high specific strength and specific stiffness. In addition, reinforced plastic structures have improved fatigue resistance, greater toughness, and higher creep resistance than similar structures made from steel. So, types of fibers are grass fiber material, carbon fiber, armid fiber materials. So, it is a grass fiber and aramid fiber and carbon fiber. Some plastic laminates. So plastic laminate is a one more composite building material made from kraft paper, resin and adhesives. Multi layers of kraft paper and soaked in resin then pressed together at high levels of temperature and pressure to form a single sheets. Plastic laminate adhesive or resin is then used to add a decorative paper or melamine top layer. A protective urethane top coat or where coat is added to enhance strength and durability. Decorative laminate is commonly used to surface kitchen counters, tabletops, and cabinetry because of its resistance to strains, scratches, and heat. Next, coming to the types of plastics. Usually, on the basis of molding property of a plastics has been classified into two types, that is thermoplastics or thermosetting plastics. So what is a thermosetting plastics? So type of plastics formed by chemical reactions which leave them in a relatively fixed state. Fixed state. That means those plastics become hard and cooling, so it cannot be molded into initial stage. That type of plastics are known as thermosetting plastics. So thermosetting plastics are the plastics. Those plastics does not remolded once reaction is completed. They does not come to the initial stage. So that type of plastics are known as thermosetting plastics. Thermosetting plastics are formed and set in a single operation when a chemical reaction leaves them fixed in the shape of the mold. They cannot be softened or reformed when reheated. Although thermosets can be withstand high temperature, excess heat will simply cause the material to decompose. An egg yolk is a good analogy for this. When a yolk in law, it is a soft liquid state, but if it is heated, it becomes hard and is no longer capable of becoming soft. So that is a well example for thermosetting type of materials. Egg yolk is the very well-known example for thermosetting plastics. So thermosetting plastics are often used when a product needs resistance to extremes in temperature, electrical current, chemicals, and wear. These are some important thermosetting plastics. And let us see one by one. So epoxy resin, ER, first one. So common name for epoxy resin is Aeronautical. Properties and workings and characteristics are, so Aeronautical is excellent adhesive qualities, low shrinkage, strong when reinforced, and uses of Aeronautical bonding, encapsulation, laminating surfaces of coating. And second thermoplastic is melamine formaldehyde, MF. So common name of MF is Formica melavare, and properties of MF is it is a waterproof, tasteless, odorless, mark and scratch resistance. And uses of MF is it is used as a worktops, tableware, buttons, and electrical insulations. And next thermo setting plastic is urea formaldehyde. So common name for urea formaldehyde is aerolite cascamide. So coming to the properties of urea formaldehyde is it acts as a good adhesive, qualities stiff, hard, brittle, and good electrical insulator. And coming to the uses, it is used as a electrical fittings, paper and textile coatings, and wood adhesives. And next thermo setting plastic is polyester resin (PR). Common name for PR is OLED brittle. So coming to the properties of PR: stiff, hard, brittle, resilient as laminated, GRP, and formed without heat and pressure. And coming to the uses, polyester resins are used as a panels for car bodies and hulls, casting, embedding. So these are the some thermosetting plastics. And one more thermosetting plastic is GRP, grass reinforced plastics. So coming to the properties, these are strengthened by grass fibers, mats of grass fiber being sandwiched between layers of polyester plastics. And coming to the uses, used as a boat hulls, bodies, and some structural components of high performance cars and aircrafts. And next one is carbon fiber plastics. So these are strong, lightweighted, higher strength to weight ratio, durable, and very expensive. And these are used as modern bicycles and soil boats. And next one is epoxy resin. So it is a aerate. Many adhesives groups are thermosetting plastics. A good example is aerolite, which is an epoxy resin that hardens when a second chemical is added as a catalyst. So it will bond most material including woods and metals as well as some plastics. So it is act as a good electrical insulator and it is a hard, brittle unless reinforced resistance to chemicals well. It is a melamine. Melamine also known as Famica or Melaware. So used in production of plastic laminates because of its smooth surface and hygienic quality. So it is a waterproof, odorless, mark and scratch resistance. These are importance of the melamine and uses used in making of worktops, buttons and electrical insulating materials. So this is a urea formaldehyde. So common name is aerolite or cascamite. It is used in homes as an adhesive resin in pressed wood products. And properties of ureoformaldehyde is it is good adhesive qualities. So it has stiff and hardened brittle and good electrical insulator. And coming to the uses, so electrical fittings, paper and texture coatings, and wood additives. So urea formaldehyde resin is used as a electrical fittings, paper and texture coatings, and wood adhesives. These are the polyester resins. So common name of polyester resin is Borer albutyl. And properties of polyester resin is it is also stiff, hard, and brittle, least silent as laminated GRP, and formed without heat and pressure. And coming to the uses, so it is used as a making of panels of for car bodies and boat hulls, casting and embedding. And GRP, one way on reinforcing plastic is to add fiberglass to it. This make it much stronger and generally referred to as GRP. So GRP stands for grass reinforced plastic. GRP is used in car body repairs, sailing boats, and corrugated seats because of its lightness, toughness, and resistance to the water. And these are some thermoplastics and thermosetting plastics. Some case studies are examples for thermosetting plastics. So we can see here some transparent polycarbonate plastic panels with a colorful fixated backdrop from the walls of its sports walls of this are in Gairona. So creating a visually lightweight edition with an ethereal quality that matches the colors of the sky. These are the plastic houses. In Tokyo, thermosetting plastics are used to construct some houses. The house was designed for a photographer and is located in densely built residential area. So plastic was chosen as material for the building to achieve lightness and opens. The plastic strip to the garden fence and veranda and balcony provided both screening and opens. Many other details from the staircase test to certain fixing were also executed in plastics. So that is about thermosetting plastics. Now let us see the thermoplastics. So what is a thermoplastics? So thermoplastics are those plastics will become soft on heating and at a time they will become hard on cooling. So this type of plastics are known as thermoplastics. Here remolding we can observe in case of thermoplastics. So substances that become plastics on heating and harden on cooling and are able to repeat this process that are known as thermoplastics. A thermoplastic or thermo-softening plastic is a plastic material, a polymer that becomes moldable above a specific temperature and solidifies upon cooling. These are crystalline thermoplastics. These are transient or opaque, good fatigue resistance, tendency to toughness, and good chemical resistance, good sliding characteristics, and wear resistance. And coming to the amorphous thermoplastics. So, on the basis of properties, thermoplastics has been classified into two types, that is crystalline plastics and amorphous thermoplastic polymers. So, coming to the amorphous thermoplastic polymers, these are mostly transparent and low tendency to creep, good dimensional stability, low tendency to warp, tendency to brittleness, low chemical resistance, and sensitive to stress cracking. And second one is crystalline thermoplastics. So these are also transparent, transparent, good fatigue resistance, tendency to toughness, and good chemical resistance, good sliding characteristics, and wear resistant. So these are the types of thermoplastics. Coming to the properties of thermoplastics, thermoplastic have wide ranging properties depending upon their chemistry. They can be very much like rubber or strong aluminum. Thermoplastics are lightweight with density of 9 to 2 grams per cc. Some high temperature thermoplastic materials can withstand temperature extremes of up to 600 degrees Fahrenheit, while others retain their properties at minus 100 degree Fahrenheit. Most of the thermoplastic materials are excellent insulators, both electrical and thermal. Multiple cycles of heating and cooling can be repeated without severe damage and allowing reprocessing and recycling. They are soluble in certain solvents and swell in presence of certain other solvents. So these are the important properties of thermoplastic polymers. And these are a processing of thermoplastics. So by using these techniques, thermoplastics can be produced. So first one is injection molding technique, and second one is compression molding. Third one is thermoforming molding and bro molding. So usually these four types of techniques nowadays using to produce thermoplastic type of polymers. And advantages and disadvantages of thermoplastics. First, let us see the advantages. Thermoplastics are high strength, lightweight, relatively low processing cost, energy efficient both in their manufacture and processing. Thermoplastic can be replace metals with a considerable weight savings, providing proper care is taken in design. Most thermoplastics have better fatigue properties and then metals and will tolerate large diffractions than metals without deforming. Next, coming to the disadvantages. Some major disadvantages of thermoplastics are thermoplastics melt, some degrade in direct sunlight and under high UV light levels. Many materials have poor resistance to hydrocarbons, organic solvents, and highly porous solvents. Many thermoplastic materials, especially composites, tend to fracture rather than deform under high stress levels. And uses of thermoplastics. Acrylic. It serves as steady substitute for glass for such items as aquariums, motorcycle airmet vessels, aircraft windows, and weaving ports of submersible and lenses of exterior lights of automobiles. It is extensively used to make signs including lettering and logos. In medicine, it is used as bone cement and to replace eye lenses. And next thermoplastic is nylon. Nylon has served as a substituent for silk in products such as parachutes, breakweights, and women's stockings. Nylon fibers are useful in making fabrics, rope and carpets, and strings for music instruments. In work form, nylon is used for mechanical parts including machine screws, gear wheels, and power to castings. Polyethylene. It is used to manufacturing moving machine parts like bearings, gears, artificial joints, and some bulletproof vests. High density polyethylene is used to make milk jugs, tubs, and water pipes. Medium density polyethylene is used for packing films, socks, and gas pipes and fitting. And low density polyethylene is used as soft and flexible and used in manufacturing of squeeze bottles, sacks, and sheets. And polypropylene. It is also a type of thermoplastic. It is used for such diverse products such as reusable plastic containers, sanitary pads, ropes, carpets, and plastic molding piping systems, car batteries, insulation for electrical cables, and filters. In medicine field, it is used to repair hernias, and to make heat resistant medical equipment. Polypropylene sheets are so used to stationary folders and packing and storage boxes. And polystyrene, it is used in manufacturing of disposable series and DVD cases, plastic models of car and boats. Expanded polystyrene foam is used in making insulation and packing materials such as peanuts and molded foam used in cushions, fragile products. Extended polystyrene foam, known by the trade name styro- styrofoam, it is used to make architecture models, drinking cups for heated beverages. Polystyrene copolymers are used in manufacturing of ties, toys, and product casings. Polyvinyl chloride. It is one of the thermoplastics. So it is a tough, lightweight material and that is resistant to acids and bases. Much of it is used by the construction industry, such as for vinyl siding, drain pipes, gutters, and roofing sheets. It is also converted to flexible forms with the addition of plasticizers, thereby making it useful for items such as tubbing and electrical insulation, coats, jackets, and etc. Flexible PVC is also used in inflatable products such as water beds and pool toys. And one more thermoplastic, that is Teflon. It is a famous coating for non-stick cookware, being chemically inert, and it is used in making containers and pipes. And it is also used as a lubricant to reduce wear from friction between sliding parts such as gears, bearings, and bushings. So this is some cost comparison in between the thermoplastic and thermosetting materials and uses. Some reinforced plastics and fixed extensive use in many fields such as automobiles and corrosion resistant equipments like fiber reinforced plastic tanks, vessels, etc. And advantages: FRP arrows arrangement of the grass fibers of thermoplastics to suit specific design programs. Specifying the orientation of reinforcing fibers can increase the strength and resistance to deformation of the polymer. And coming to the disadvantages, tensile forces stretch the matrix more than the fibers, causing the materials to shear at the interface between matrix and fibers. Tensile forces near the end of the fibers exceed the tolerance of matrix, separating the fibers from the matrix. Tensile forces can also exceed the tolerance of the fibers, causing fibers themselves to fracture, leading to the material failure. Let us see the differences between the thermoplastics and thermosetting plastics. So in thermoplastics, no links between the polymer chains. It helps the freely moves. Here these are the monomers. So there is no linkage in between the monomers in case of thermoplastics. Whereas in case of thermosetting plastics, some cross linkages are found between the monomeric units. So these are the cross linkages. So due to the formation of these cross linkages, it will become hard. So let us see the differences between the thermoplastics and thermosetting plastics. So thermoplastics are soft on heating. Thermosetting plastics are do not soft on heating. Thermoplastics are long chain linear polymers, whereas thermosetting plastics are 3D structures. Thermoplastics are formed by additional type of polymerization reaction. Thermosetting polymers are formed by the condensation type of polymerization reaction. Thermoplastics can be reshaped and reused. Thermosetting plastics cannot be reshaped or reused. Thermoplastics are soft, weak, and less brittle, whereas thermosetting plastics are hard and strong. Thermoplastics are soluble in some organic solvents, whereas thermosetting plastics are not soluble in organic solvents. So, in case of thermoplastics, it can be reclaimed for wastes, whereas in case of thermosetting plastics, it cannot be reclaimed. So, these are the major differences between the thermosetting and thermoplastic polymer. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.